Hello, Algebra 1A students. This is your review video. The way this is going to work is I'm basically going to go through the review and do the problems and then show you the answers. If you want to skip ahead for each section to the answers and then go back and watch the ones you got wrong, feel free to do that. It's just kind of how you want to do it and what works best for you. Okay, so I'm going to go ahead and get started. Here we go. So ELR 2.1 is translating expressions, and the directions say, translate the following statements from words to mathematical symbols and from mathematical symbols to words. So I have 2 less than a number is 10, and less than and is are my operation words. So I have is 10, I know is going to equal 10. 2 less than a number, I'm going to pick x to be my variable, and 2 less than something means I'm subtracting 2, right? 2 less than 4 is 2 because you take 4 minus 2. So my answer should be x minus 2 equals 10. B says a number divided by 6 is increased by 12. I have divided, is, increased. Those are my 2 operation words. So a number, let's do n divided by 6, increased by 12. Okay, increase, remember, is addition. You can also have it look like this or like this. Either way works. Okay. Now, 1 equals 2x plus 3, those are symbols, so we have to turn it into words. So I'm going to say 1 is equal to, well, 2x, I'm going to say 2 times x plus 3. Now, you might have a different answer, so you just kind of have to decide, is it similar to mine? Okay? For D, it says circle all the statements that correctly describe the equation 3x plus 7 equals 4. So 3 times a number less than 7 is 4. Well, less than is subtraction, and there's no subtraction in here, so that one doesn't work. 7 plus 3 times a number equals 4. Okay, 7 plus 3 times a number. Yep, okay, that one works. 4 is equal to 3 times a number increased by 7. 4 is equal to 3 times a number increased by 7. Yep. The sum of 3 and x plus 7 is 4. Ooh, you know what? Sum is addition. So that would say 3 plus x, and we have 3 times x, so that one is not. So you should have B and C circled. Okay, 2.2 says evaluate each expression for a is equal to negative 3, b equals 7, and z equals 3. So everywhere I see an a, I'm going to put negative 3. Everywhere I see a b, I'll put 7, and z, I'll put 3. So let's start with a. So 5 plus b, 5 plus b, well, b is 7 over a. Well, a is negative 3. Okay, 5 plus 7 is 12 over negative 3. 12 over negative, well, 12 divided by negative 3 is, 12 divided by 3 is 4. Positive divided by a negative is a negative. So you should have gotten a negative 4. B, a is negative 3 plus b squared, which is 7. Order of operations tell me to do 7 squared, which is 49, plus negative 3. Okay, so when I'm adding a negative, it's really 49 plus negative 3, which is the same as 49 minus 3, which gives me 46. Okay. C, when they're right next to each other, remember that means multiplication. So 2 times negative 3 times 7 minus 2 times z, which is 3. So 2 times 3 is negative 6 times 7 minus 2 times 3, which is 6. Negative 6 times 7 is negative 42 minus 6. Okay, so negative 42 minus another 6 is negative 48. Okay? All right, so for 3.3, annotating a problem, I've given you the steps of annotation for you to do. So, here we go. Jane spent $42 for shoes. The new blouse she bought was $1 less than twice what she spent for her shoes. How much was the blouse? How much did she spend total? So I'm going to underline my questions. How much was the blouse? And how much did she spend total? I'm going to say this one's level 1. And I'm actually say this one's level 1 too, because both of them are going to have that answer of a number. So here's my plan step for how much was the blouse. I'm going to write an expression. B, let's say S equals shoes. Okay, and it's going to be $1 less, so minus 1, then twice what she spent on shoes. And she spent $42 on shoes, so 2 times 42 minus 1, 84 minus 1. So she spent $83 on shoes. Oops, you can't see that, sorry. All right. Step 2, how much did she spend total? Well, total means we add, so we take 83 plus 42, and we should get, well, 80 plus 4 is 120. 3 plus 2 is 5, so 125 total. Okay, I've answered both of my questions. They have units. I'm good to go. Okay, let's check out B. So, Jenna learned a total of 8 appetizer recipes over the course of 4 weeks of culinary school. After 8 weeks of culinary school, how many total appetizers will she know if she's learning at the same pace, and how many appetizers would she learn per 16 weeks? So I'm going to underline the first question. I'm going to say that's level 1. How many weeks per 16? I'm going to say that's question 2, and that's level 1 as well. So for 1, I know that for 4 weeks, she learned 8. So if we have 8 weeks, well, 8 weeks is twice as long as 4 weeks. So I know that she's going to make twice as many apps, so that should be 16 apps. For 2, my plan's going to be similar, right? So 4 weeks was 8 apps. 16 weeks, well, that's times 4. Well, 8 times 4 is 32 apps. Okay. Have I answered my questions? Yes. Have I put labels? Yes. I'm good. Okay, 2.4 is interpreting expressions. Roland weighs K pounds. His brother Ethan weighs M pounds. Roland wants to lose G pounds. What do the following expressions represent? So here we're taking Roland's weight and we're adding Ethan's weight. Well, that's really their total weight, right? Their weight combined. For K minus G, we're looking at what Roland weighs now and then how many pounds he wants to lose. So really we're looking at what he weighs now minus what he wants to lose. So we're really looking at his goal weight. Where is he going to be after he loses all that weight? Okay? Let's talk about B. So B, Kayla drove H miles in 2 hours in her truck. Later in her SUV, she drove G miles in 2 hours. What do the following expressions represent? So H plus G. So we're looking at H miles in her truck, G miles in her SUV. So this should be total miles driven in both cars. Okay. How many hours did she drive? Well, 2 hours in her truck plus 2 hours in her SUV. That's 4 hours. Okay. C, write an expression to find how many more miles Kayla drove in her truck than in her SUV. So how many more tells me it's going to be subtraction. And we want to find how many more in her truck, which was 8, than in her SUV, which is G. So that should be H minus G. Okay? Okay, moving on. ELR 2.5 is distributive property, and we're going to use the box method. So I'm going to draw my box here. -4 is my width. A is this part. 3 is this part. So then I'm looking at area. -4 times A gives me -4A. -4 times 3 gives me -12. So my expression is -4A minus 12. If you put -4A plus -12, it's the same thing. That's correct. Okay, for this one I'm going to have a box with a width of 6 and then a length of M and 1. So 6 times M is 6M. 6 times 1 is 6. So this should be 6M plus 6. Let's look at C. Again, my width is going to be 6, my length is going to be 3, and then -4y. Okay, that negative comes from right in front. You have to take it with it. Okay, so 6 times 3 is 18. 6 times -4y, well, you multiply the coefficients. So 6 times 4 is 24. That's a positive times a negative, -24, and then add our y. Again, add them together, 18 minus 24y, or 18 plus -24y works as well. Those are the same things. Okay, so let's talk about C. So it says fill in the blanks so that the statement is true. So we have to find out what did we multiply by up here to get these down here. So I have 2 width. What do I multiply 2 by to get 2x? Well, like up here, I multiplied -4 times a to get -4a. I'm going to have to multiply 2 by x to get 2x. If you put 2 times 1x, that's totally fine. What do I have to multiply 2 by to get 10? Well, 10 divided by 2 is 5, so it should be 2 times 5 equals 10. Done. All right, of course, the hardest, last, and worst. Simplifying expressions. Simplify the following expressions. We're going to do this by combining like terms. So the first thing I'm going to do is, in A, do I have any parentheses to get rid of? No, not really, so I'm just going to box my like terms. So here's a like term, and here's a like term. This guy's all by himself. Okay, so I have xy minus 4xy. Actually, let's start with x. X is all by himself, so we're just going to have x. And then we have xy minus 4xy. So remember, when there's no number in front of the variable, there's that sneaky little 1, that ninja 1. So we're going to take 1, and because this is a subtraction sign instead of the first one, we're going to take 1 minus 4. 1 minus 4 is negative 3, and then we have to add on our xy. Okay? Let's try B, and let's see if we can get this shadow thing from stopping to happening. I'm not sure that'll be the case because it's just too bright. Okay, so I do have some parentheses here that I want to get rid of, so I'm going to distribute that 2 to the 6y and the 5. So 6y plus, well, 2 times 6 is 12, and we tack on our y. And then 2 times 5 is 10, so plus 10. Now, we have some like terms here, 6y and positive 12y, and again, 10 is by itself. So I'm going to add 6 and 12 because it's 6y, and then in front of this is plus 12y. So 6 plus 12 is 18, tack on our y, and then 10's by himself. Okay, let's talk about C. So I have some like terms here, and some like terms here and here. Let's start with the squareds. 9y squared, negative 7y squared. I'm going to subtract those because of this subtraction sign. It's in front of the second one. So 9 minus 7 is 2y squared. Here, I'm going to add these y's because this is a plus in front of the 6 on the last one, so that should be 12y. These are not like terms because this has an exponent, this doesn't. I'm done. Okay, D. Circle all the expressions that are equivalent to 4x plus 6y minus 2x. Okay, well, if I went ahead and simplified that, these are like terms here, so I'd have 6x plus 6y. Actually, that's on there, so I'm going to go ahead and circle that. These are not like terms, so I can't combine them. So 10x is definitely not 1. However, if I distribute this one, it would be, okay, ninja 1 in front of the x, ninja 1 in front of the y. 6 times 1 is 6x, 6 times 1 is 6y. Hey, that's what we have here. So that is the same. And this one, I'm just seeing that they move this 2, they switch this 2x and this 6y. Well, that's addition, and addition is commutative, so yeah, that's totally fine. So you should have 2, 3, and 4 on all of those. Okay, so you should know which ones you have right, which ones you have wrong. Please come to office hours if you have any questions. Otherwise, we can do some quick questions in the morning on Wednesday when we start to, or Wednesday or Thursday when we start to review this.